And we are live. Welcome. Hello, 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 hello. Hello, 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 hello. Welcome to LaserBeam Live. This is episode number 16, 22, 29, 37, I think 43, 44, 50, 50, halfway to 100. Thank you for joining me. My name is Ikenna for CNC Labs, and you know the drill. Wherever you are, whether it's morning, afternoon, evening, or night, I appreciate you spending a little bit of time with me. We're cozy, we're chill, we're feeling it, we're feeling good. What time is it, guys? It is almost time to end the stream. Before I go, I'll give you my spiel. You know the deal. My name is Ikenna for CNC Labs. And whether it's morning, afternoon, evening, or night, I appreciate you spending just a little bit of time with me, your boy. And that is a wrap. 730 days, 52 episodes, and 2 years of LaserBeam Lives. My name is Ikenna. Thank you so much for supporting the show. Thank you so much for supporting us as a company, the content, being in the live streams, commenting, everything. I appreciate it. And I'm not going away forever. This is not a series finale. This is just a season finale. I will be back with something, hopefully, a little bit more exciting, and we'll continue from there. So until then, I need a rest. I need a little break. But just know that every single one of our live streams is cataloged on our YouTube channel. So you can always go back and relive the glory days. I will catch you in a couple months with something hopefully a little bit more interesting. And yeah, thanks. Bye. Hello, hello, hello. I'm sorry to do this to you guys after watching all that, but welcome to LaserBeam Live. This is episode number 52, and you know the deal. My name is Ikenna for CNC Labs, and whether it's morning, afternoon, evening, or night, I appreciate you spending just a little bit of your time with me. Un poquito time. With me, thank you very much. This is our season finale. Not a series finale, a season finale. And thank you so much for joining me. Big shout outs to Molly, our head of marketing. She's always helping me with all the marketing for this live stream. And a big shout out to Paulo, one of our videographers and cinematographers, for editing that video. Anytime I have an idea for a bit of laser stuff, I always just send it off to him, and he always gets it done in spectacular fashion. I explained the vibe, and he kind of knew exactly what I was going for, and he whipped that up, and then we filmed a little outro. So I thought it would be cool for you guys to watch, but I also wanted it just for myself. Like 52 episodes, 2 years is a long time. And I'm not a very sentimental guy, but it did feel good to kind of take a moment to appreciate how long we've been doing that, how long you guys have joined me on this. And Molly and our head of HR, Jess, also thought that, and they actually bought a cake for me. And I'm sorry, I should have took a picture before I cut it all up, but it was like, congratulations on 2 years of LaserBeam Live, and that was very sweet. And I gave a terrible speech just for fun. And it was great. So it was great to have everybody kind of take a moment. And, you know, if I didn't, I would have never taken that moment. So I'm glad that we have some people in the office that are forward thinking and did take that moment. And I am very much appreciative. Let's go through the chat. You know, Bill, thank you so much for joining us. Nicholas, thank you for joining us. Scott, thank you for joining. This is not our usual day because I am leaving for a quick trip overseas tomorrow, just for a couple days. I'll be back on Monday, but I didn't want the last LaserBeam Live to not be live and pre-recorded, so I changed it to Wednesday just so I could be here. Molly, thank you so much. Thanks for joining. And yeah, so there is no project today. I'm just letting you guys know that. There's no project. I didn't plan a project. I didn't want to have to think about a project. I just wanted to relax and chill and kind of just vibe out with you guys. Hold up. I feel like I had a Zeus camera. Okay, so instead of a project camera, it's now a Zeus camera. Zeus, how you doing? You a good boy? Yeah, he's just staring. I see you. I see you, buddy. Yeah, so yeah, today's not about a project. Today's just about kind of a little bit of a retrospective, looking back and looking forward, okay? Taking a moment to kind of see what we did and see where we're going. So, yeah, we can kind of break it down into like a few different parts. So the future of the LaserBeam. Um, Actually, I'll start with myself. How I personally feel about all of this. So I've made content and videos for a long time. First for my company, my startup, then for CNC Labs, then for myself, just personally, I made content and uploaded it in different form factors. But the first time I ever live streamed was not for this company, it was for myself, and I just did it for fun over the pandemic, and I really liked it, and I liked the format. I liked being able to kind of just do my thing. I don't really have to think about it. I'm not a great writer, but I feel like I can write great stuff. Will never sit down and start typing stuff out. I feel like I can freestyle my thoughts very well, and I think live streaming just kind of, matched up and clicked perfectly. And yeah, so we needed a way to kind of market and do customer service, right? Or a little bit of tutorials and all that stuff. And rather than having to edit entire videos, just like we do for the router jobs or Vortex jobs, we found that it might be a better idea for us to just have a live stream. So every week we can just come in, do a project. I show you guys Lightburn, GSender, get to talk about all the stuff that's happening in the office, any new updates for projects, and then you guys get that every week, and then it gets saved as this hour-long video. So it is kind of like a tutorial, an unedited tutorial, but also gets to be like a little bit of a community. And I think we accomplished that, because right now, if we go back, we have about 51 tutorials. Some are in multiple parts. Most of them are just single video tutorials where we start a project, we design a project, we run the project, and we finish it. Sometimes it takes more than one day to finish the project. We have to come back. Sometimes it finishes off stream and I have to show you guys the finished product afterwards. But I think we accomplished that part of the goal where we have this library of just information, me dealing with issues, me dealing with trial and error. I tell you guys, hey, this is what the speed and the power that I would use, but it's going to be a little bit of trial and error. And you guys may hear that, but you guys got to watch it and actually see the trial and error and know that, like, hey, I'm doing the exact same things as you and I'm figuring it out, and it's a blast, and we make a bunch of cool stuff. And hopefully you guys have taken that and gone very far. Hopefully we've answered a few questions. Maybe we've showed you how to do something you didn't know, or you personally asked in the chat and I was able to help you. That was like A+. Like, number two, it was a bit to just show what the laser can do, right? It's very exciting. It's like this little add-on that can open up a whole new world of what you can actually do with the long mill, and that was very exciting for me. And yeah, I got to, like, it forced me essentially to do my own testing, right? To do my own kind of, customer input. Like, I designed this thing, I shipped it, we sold it. I do the customer service, I do the technical support for it, but now every 2 weeks I get to actually be the user just for like an hour or two, and I actually get to like explore like what frustrates me about it, what I love about it, what I find easy, what I find hard, what I found fulfilling about it, and I got to be like kind of the customer. And I think that improved and made me a better product developer, made me a better product manager in terms of this laser. So boom, that's like check number 2, we accomplished. Lastly, we got to build this community. Guys, yeah, like Jack in the shop, Nicholas, Bill, like Scott, Lester, thank you so much. Lester says, thank you for everything. Lester, thank you for everything. It's literally the support of you guys. If nobody was in this chat, if nobody was watching, I would not be doing 52 of these live streams. So I appreciate you. I feel like I'm talking like this is over, but it's not. We're just moving on. I am so excited and so focused on the UltraBeam. When I look back on my career and a little bit, let's say over the past 2 years, moving in from the head of operations and that stuff at CNC to product development and kind of being the laser guy, essentially, a few things that I've learned, and especially recently, is prioritization is key. Guys, me personally, for what the LaserBeam is, I think it's a perfect product. For what it is, which is an add-on for the long mill, I think it's a perfect product. It's not perfect in terms of I like all the little things that we can improve upon it. But for what you get, the bang for buck and the support that you get with it, the complete support that you get with it, I think it's an amazing offering. But for me, it's time to focus and prioritize the next offering, because I can only make the UltraBeam, the CO2 laser, the best product ever if I find a way to prioritize it and focus on it. And that's what we're doing here. So when I say the live streams aren't ending, they aren't, because we're going to come back, but they're going to be focused on the UltraBeam. So before we actually open everything up for pre-launch, you'll see me doing projects on the UltraBeam. And hopefully it'll be a pretty direct contrast between what we can do on the LaserBeam and long mill to what we can do on the CO2 laser. For the future, for everybody who wants higher power diode lasers, you're just like, hey, CO2 is not for me. I will look at finding a supplier for higher power diodes probably later next year, because I know there's third parties, and I'm trying my best to support them. I'm never going to turn you guys away. I'm going to try my best. If you guys have an issue, even if it's with a third party laser, but you're using it with the long mill and you just need some help, I'm here to help, and I continue to try to help. Of course, we can't guarantee that we'll fix your issue because it's not our product, but I've put in a lot of hours troubleshooting lasers that aren't CNC lab lasers, and that's totally fine with me, because it really is about the customer experience that you guys have. And if it's laser related, I'm here to help. But yeah, CO2 laser is my ultimate goal. And at this point, I would say I'm 70% done the design. I have a linear system, XYZ, I've ran at about 660 millimeters per second. So exactly 10 times faster than what the long mill does. And I've ran it at 750 millimeters per second. But there's some tolerance issues because I have 3D printed parts and stuff like that. But when I'm ready to do a pre-production model and send it off to CSA, I'm going to be very excited to make sure all my parts are steel or aluminum and get all those tolerances in check to make sure that I know the components and the design, it can do 750 millimeters per second plus. My goal is to hit 1,000 millimeters per second, even though you will never run your laser that fast, guys. The CO2 laser, it just can't fire that fast, like just right off the bat. You would need an RF laser, which increases the cost of lasers like this by like $2,000, $3,000, $4,000, $5,000, $6,000, $7,000 when we switch over glass tube to RF laser tube. And that's the only way you can actually run projects that fast. But being able to reach those speeds means that when you guys are actually running it at like a relatively fast speed for CO2 lasering, which is like something like 200 millimeters per second for an engraving, let's say, you will not be running it anywhere close to the max speed. You might be 1/4 the max speed, 1/5 the max speed, which is going to prolong your parts, right? The belt, the pulleys, the idlers, the motors, the drivers, everything. You're going to be running it so conservatively, but still running it extremely fast. So yeah, we have a fully built, essentially linear system. XYZ has 2 inches of Z travel, 36 inches by 24-inch bed. Semi-enclosed gantry system for the belt and the linear guides, right? So the particulate and the smoke isn't going to build up on your linear guides, and it's going to be less maintenance. And right now we are about halfway done our enclosure. So we're building it. The prototype enclosure is going to be made out of ACM extrusion and some plastic parts. But the end game is going to be injection molded custom extrusion parts and paneling that we make custom in order to build this beautiful enclosure. And that's what I want to get to you guys as soon as possible. So my goal is the end of the month and to be able to show you guys that. But that's why I am prioritizing that. So even when I come back with these live streams, it's going to be CO2 focused. My goal is to get this thing safetied and certified so we can get pre-orders up and then we can get shipping as soon as possible, right? We're kind of wrapping up the end of this life cycle or the launch cycle of, hey, Kenny, thanks for joining. But yeah, we're kind of wrapping up the life cycle or the launch cycle of the alt mill right now, where we're trying to ramp up production and make small improvements. And then hopefully by early next year, we're starting the pre-order cycle for the CO2 laser, the UltraBeam. And we're doing the exact thing that we did this year with the alt mill, where we do a small batch, then a larger batch, and then we start ramping up production to a higher level. So there's no lead times, essentially. Thank you, Kenny. I also love CNC Labs. Let's check in on Zeus. He's chewing on his foot. He's itching his ear. Zeus, do you have allergies? We're just doing a midstream check-in on Zeus. He's doing good. Grooming. He's grooming. He's nibbling his feet. He's licking up. Okay, he's good. Kenny says that he's looking to install Fluid NC on SLB. I've heard about Fluid NC, and I heard it's good. Although I do still believe that Gerba HAL is just the most flushed out firmware system at the moment, like newer firmware system, but there are cool, very cool stuff like Fluid NC that people are working on, and it's always cool to experiment. I think that's the whole point of something like the SLB, was to be this open source thing where a bunch of different people and environments and communities can jump on board this piece of hardware and use it to how they want to use it. So yeah, live, laugh, Zeus. It's a live, laugh, Zeus moment. Yeah, so talked about kind of this live stream, what it meant, kind of what we're doing. We talked about the future, which is the focus, the prioritization of the CO2 laser, because that's the only way we're going to actually get it to a point where we are launching and we are shipping and we are, you know, taking pre-orders and all that fun stuff, is to prioritize it and focus. For the LaserBeam, the future of the LaserBeam, one of our, like, essentially my head of operations for LaserBeam, she assembles, she does customer service for me, she does test the lasers, she does so much for the LaserBeam, and I'm at the point where I'm trying to level her up in terms of her technical support ability so that she can kind of start to take over, and that's part of me kind of prioritizing the CO2 laser, because she is very competent and very skilled, and she will be able to take it over. And it's just about making sure that she has everything she needs to feel very comfortable and to continue to service this community. And I'm not going anywhere. I'll always be here to help and to jump on calls and stuff like that whenever I'm needed. But it's kind of growth, and it's moving forward, and it's kind of figuring things out and kind of putting coming to the end of a project management cycle before starting another product, or ending or continuing another product development cycle, right? It's to be able to kind of close the book on these projects is a big part. It's something that I didn't really focus on. I just focused on maintenance and kind of keeping things going and keeping things moving. But I think now it's time to focus on how do you actually wrap up a project, essentially a product management cycle, and how do you pass that off to people who will continue its legacy and keep it going. But yeah, so the magnetic mount, I have samples. I have about, oh, just did a thumbs up. Whoa, my camera, is it lagging on your side? Because I see my mic is working. I see my mic is working, but is my camera working? Whoa. Sorry, guys. Am I all good here? Oh, I'm frozen. Okay. Let me... Sorry, guys, I'm back. Are we good? Could I get a... Oh, I'm not doing the thumbs up again. I don't want that. Whatever that was, that thumbs up thing. Okay, it ruined me. Guys, let me know in the chat if you guys are back. Okay, we're good. Thank you. My OBS just reset it. But what was I saying? Kind of the future of the long mill is going to be, we have sample magnetic mounts. So I gave one to Scott today, and I'm going to be giving one to a few other people and getting some testing and doing some testing myself on the alt mill and the long mill to make sure that we are all good before we start shipping that out. The resource section is already done. We'll get the page up, and we'll get a small batch kind of packed and ready to go for you guys. And then we'll kind of gauge your interest. If 100 people want it and we ship 100, that's cool. If 300 people want it and we ship 300, that's cool. But we'll do a small batch, a small assembly, just to make sure that you guys want it, and then we'll ship it out to you guys. But yeah, you'll probably see a video coming when that's ready to launch in the next couple weeks. My goal is to get that everything out in the product page up before the end of the month, and then we're shipping within 4 weeks. So product page up in 2 weeks, shipping in 4 weeks. So a 2-week lead time between the pre-order or the order kind of page being up and then actually shipping it, just for some time for packing and assembly. So obviously the past like 2, 3, 4 months I've been using past 3, 4 months, I've been using the magnetic mount prototype here. So you can see that I haven't had any issues with it. But you never know. We always just want to do some thorough testing and make sure that we are all good for that. So that is my goal for the next 2 weeks, is just to get a little bit of testing done, and then get that out and then move on to the next little add-on until we start stacking the add-ons to make you guys, for essentially whatever you guys need in terms of little things. So it might be the honeycomb bed, it might be the Pro Air Assist. I believe the Pro Air Assist might take a little bit longer to figure out the kinks, but the honeycomb bed will probably be ready relatively quick. So yeah, we'll just do it one thing at a time and then close that book and then open the next one. And we'll do it very kind of meticulously, but we'll try to move as fast as possible to make sure that we are, the things that we are suggesting and the things that you guys are saying that you want, we are getting it out and then moving to the next one. So magnetic mount in the next 4 weeks, that is my goal. And yeah, keep an eye out for that. You'll probably get a video and everything, and then yeah, you guys will be able to order that. What else is there? Guys, I think this might be a little bit of a shorter stream. Would you guys hate me if I did a bit of a short? No, it's the last one. We'll do our hour, okay? Let me know if you guys have any questions. I don't know. I don't want to just keep talking. I feel like I'm talking your ears off. Scott says honeycomb would be sweet. Yeah, I know. I've been playing with this, and I'm gonna order some samples just for my prototype lasers because I need a bed anyways. But I'm gonna continue to play with this, and I think it's like if you guys want it, you guys want it. We'll do small batches, so we're not really holding too much inventory for any specific item. Can also, like, I'm thinking, like right now I'm going to start testing like manufacturers for multi-diode lasers, blue light lasers, because I know not everybody's going to want a CO2 laser. So I'm going to start that testing, but it's going to be, I'm going to let you guys know. It'll probably be sometime next year that we might be able to offer like a 20-watt laser, 25-watt laser diode attachment, because we do want that to grow with the alt mill as well, because the alt mill has faster speeds and everything. But because it's a blue light, you'll still be dealing with like material that you can't cut, like clear acrylic, any transparent acrylic, certain color acrylic, you just won't be able to cut. And that's still one of the downsides of using a blue light diode. So even though, you know, out on the market, you might see 60-watt blue light diode, I feel like clear, transparent, and certain colors of acrylic are just some of the best material to do projects with. And just to cut that out completely and only have opaque acrylic kind of just sucks. And yeah, I like the form factor of a CO2 laser as well for exhausting. But yeah, I'll also be playing with new enclosure designs and see if that takes me anywhere. But yeah, like I said, one thing at a time. I'll let you guys gauge the seriousness of what we do next, probably through surveys and stuff like that. But yeah, first things first, magnetic mount. In terms of the CO2 laser, so I can kind of take you guys through what my design philosophy is for the CO2 laser, just so you guys can get into my head, into what to expect. And I have a few things where, you know, my philosophy for this product development, like a few months ago, I kind of laid out what it was because I needed kind of a guiding principle, because you could just get lost in the sauce. Kenny, no. You will always need the laser driver. The SLB is not a replacement for the laser driver. The laser driver takes in your AC, like your power supply, and actually converts that into a constant current driver. It's a very specific piece of electronics that you have to specifically design for. So, and it produces a lot of heat, and you have to dissipate a lot of heat. So just, it's its own standalone thing. You still have to plug it in to the SLB. That's something we'll be working on, is more resources for the people who switch from a longboard to the SLB. I think we're getting enough people that a lot of our tickets are people just having a little bit of trouble and needing a little bit more resources and help doing the switch over, because people are telling us that, like, hey, my long mill or my laser works perfectly on my normal longboard, but I made the switch over and I'm just having a little bit of issues. And we know it's not hardware, so we're gonna work on the resources. So Yeah. So, yeah, for the CO2 laser, I have some design philosophies. So, just to kind of keep me kind of like my head focused on what actually matters, and listing that out and deciding what actually matters for me and for what I think is going to be the best for the customer. So first things first is design to comply with IEC, which is the International Electronics Committee IEC, electronic, laser, EMC, and ROHS standards. So like, what is all that gibberish? So the International Electronic Committee is the people who actually design the standards and tests for like electronics internationally. Hey, it's our resident laser team and Jack in the shop. Oh my God, thank you for joining me. What a legend here. But yeah, so the IEC kind of dictates what these standards are going to be for most electronics, and then most countries use their standards as a basis to build out their own. Most countries don't change a thing, right? Some countries change very tiny things, but that's why the IEC is a great standard, because it was meant to be international. It was meant to kind of create this a bit of uniformity, so you're not having to comply to a billion different standards from every different governmental body, and not every governmental body has to make a standard for everything in order to keep things safe. So IEC, so designed to comply with IEC. That's just like number one, because we're not going to ship a product that doesn't comply, because we'll just run into issues with the CE, with Canadian law, with the US law. We'll just run into a bunch of issues and safety. And with a product like this, you kind of want a governmental body or some body that knows what they're doing, kind of making sure that you're designed something to be safe, because when you ship something out, you want it to be safe. You don't want people getting hurt, or you don't want hazards to be encountered unnecessarily, right? So that's why it's first. There's electronic standards, just for regular electronics. There's laser standards. There's EMC standards, which kind of falls into electronic standards. And then there's ROHS. Oh, nice. Oh, sorry. Is the IDC stream the same day? Sorry. I switched it because I'm going on a trip, so I had to switch the thing. Like, guys, just to give you guys an example, like this DJI mics that I'm using right here, it needs to comply with certain standards. So you will see it has the UKCA standard, it has the CE standard, it has EAC, and then it has a bunch of different markings telling you. So it has the IEC 90550 has an IS standard, and they're essentially telling you what they comply to. So technically, the 905, this 60950, sorry, I'm like, my brain is melting right now. 60950 is actually the general low voltage directive, but that actually got switched over to, I believe it's 603.8 something, which is the new kind of AV and internet, like any kind of electronic device. So 609 used to cover most electronic devices, but now they switched over. So you see that they're complying to a bunch of different bodies, just like we have to for the laser. So yeah, EMC is just like anything creating, you don't want to stop somebody's pacemaker because your laser uses a certain part and you didn't get it to comply, and then all of a sudden somebody's having a heart attack because you're emitting something in a certain frequency or certain waves that's messing with like products like that. And then ROHS is very basic, just make sure you're not using hazardous standards. So number one rule, philosophy in my design philosophy for the laser is make sure that whatever you design, it complies with all these necessary parts of the standards that are needed. Number two, design the enclosure to look good and stand out. Let's be very honest, okay? Components for a CNC machine, whether it's a CNC laser, a CNC router, a CNC printer, or such a plastic extruder, which is a 3D printer, right? They're all CNC machines. They're linear systems. There's not a lot that differentiates them other than quality of parts, quality of testing, and then sometimes you can come up with really ingenious ways to design certain parts and design certain processes of moving these parts that could actually increase efficiencies, increase quality, increase performance. And that's where every company is making their little stamp, which is these very small tweaks, the way we design a rail versus the way somebody else designs a rail, the way we would pick out our ball bearings or ball screws versus what somebody else picks out for their ball screws, and making sure seeing whose quality is better is going to determine how one thing moves better than the other. The way you design your plate to fight against what's it called, to be rigid and to fight against deflection and things like that is going to determine your electronics, designing the SLB to run a bit faster, a bit better, a bit smoother, better with the software like G-Sender. These are where you really make up your what stands out in an industry like this. But for lasers, I feel like it all. Thank you so much. Thank you so much. A little bit of respect, okay? Mr. Ofoha. Ofoha. Okay, that's a Nigerian name. Igbo Nigerian name. Mr. Ofoha. Okay, thank you, Jack, for the respect. But yeah, so I believe that as long as you're above a certain standard with the mechanics, which I think we are, I think we've learned a lot in our years of linear design and making sure that our rails are very rigid and our processes are very good, and we're able to come up with these little ingenious ways of doing things that do increase performance. I think we're very good at that, but where we can stand out with this product is making sure the enclosure looks good, right? We're not talking about injection molded everything, stamped parts everywhere and making it look like Apple or whatever, like a unibody chassis or whatever. If we could afford it, trust me, I would do it. But there are really cool ways to make things, to make the shape of certain things look nicer on first view. And that's where I want to put a lot of focus in. Obviously, make sure the mechanics are good, but by nature of who we are as a company, I think that like we have that on lock already. Where I think I can put extra care where we don't in other places is how this thing actually looks, how the enclosure actually looks, and try to up the quality of something that we actually put out as a company. Number 3, design for repairability. Although this thing will come fully assembled, I want to design it just like we design our long mill, where every part can be disassembled if something breaks. If something breaks, we don't want to send an entire gantry for you to replace. We want to send you just a new belt and you can replace the belt. We want to send you a new motor and you can replace the motor, right? It's all about repairability, because unlike other companies that pretend that just because they build something high quality, it'll never break, we know that even if you do build something high quality, something will still break. So it's better to just preempt that and make something that has high repairability or ease of repairability, right? So that's number 3, design for repairability, because when you guys are calling us, talking about a belt that broke or this, we want to be able to offer very simple instructions, simple videos, simple resources, and then ship you a replacement part. That's it. And that's kind of how we do the rest of our business, how we do the long mill, that's how we do the alt mill, and that's how we want to continue that with the UltraBeam CO2 laser. So number 4 is don't develop what already works unless you can make it better. Exactly, I like that. Bill's dad always told him, if you don't have time to do it right, how will you find the time to do it over? I like that. I like that a lot. But yeah, number 4, don't develop what already works unless you can make it better. I feel like with product design, there's a lot of product designers that because something is done a certain way in the industry, they feel like they don't want to copy it. So they come up with a convoluted way to do the exact same thing, and they don't actually make it better. They just make it different or more expensive, or maybe like nothing of note was changed except physically the way something was done, or like the process of which something got done, right? Of course, when you change things, you need to have purpose for why you're changing it. So Jack asks, is the tube going to stay on the gantry? Will there be any ability to put a longer, more powerful tube in down the road? So yeah, the tube is going to stay on the gantry. But yeah, I feel like removing the back panel and having a stationary tube kind of system added is definitely going to be possible. I feel like you see that in the industry with external tube kind of enclosures that kind of stick out to the machine if you need a longer tube, and then just adjusting the way the mirrors line up is all you need to do. So yeah, because I want to design for repairability, I'm designing the panels to be removable. So if the panels are removable, then you can add kind of sections onto it with our kind of custom enclosure, with like extruded rails, right? With our custom, we're gonna have custom extruded rails for the enclosure, and that should be able to, like, if you remove a panel, you should be able to build it out. But we'll have to look into the safety of all that and make sure that we're doing everything right. But that's kind of something down the line. That's why we kind of wanted to start with a higher power laser tube, so that most people are kind of getting pretty much to their ceiling before having to upgrade. So yeah, don't develop what already works unless you can make it better. So am I going to design a new autofocus, like a new thing? Maybe, probably not. I've tried infrared, and infrared for autofocus sucks because if your material changes color, all of a sudden you have to calibrate for that color, and that just sucks. I tried capacitance, inductive sensors, and those suck because same thing. Whatever your material, what your material is made out of, if it changes, then all of a sudden the calibration changes of how close it wants to get. I've tried, what else have I tried? I've tried those cheaps, like those small, like mechanical switches that you get for 3D printers and stuff like that, and I didn't like them at all. I've tried the pen autofocus mechanical switch, and I didn't like that. I was able to break that, and it's causing me issues on my first prototype, and I didn't like that at all. So what I got was actually a plunger roller type sealed mechanical switch, right? So if it ain't broke, don't fix it. I just found a better version of a mechanical switch for my Z Focus. Some people put the mechanical switch, like our OhmTech machine has the mechanical switch for autofocus actually built into the tube. And I thought about it. It looks nice not to have something external, right? But it kind of goes against rule number 3, which is repairability, right? If one tiny little switch that's pretty cheap, I'm not gonna lie, these switches are not that expensive, right? If one tiny little switch breaks, you have to disassemble your nozzle and your tube and your lens and that whole mirror Z carriage. You have to disassemble that to replace a Z switch, right? And I didn't like the idea of that. So unless I could find a way to integrate it, like the switch that I have now, which I really like, it's high quality, it's sealed, right? So the smoke and particulate isn't gonna ruin it. Yeah, like autofocus is, yeah, like same, exactly what Jack said. Autofocus is fine, but I like having a little bit of adjustability. And if you have a removable like switch or an adjustable switch, you could just move it out of the way if you're not using it. And yeah, so unless I find a way to embed it into the current lens system, which might just be something that I do later, which is how I can make it better by having it be easy to repair, but also internally figured out. But yeah, I found a really high quality switch that's, you know, sealed against all the particulates, so the smoke isn't going to mess it up, which is usually what happens with a lot of these switches. Like my pen switch is already all messed up. It's already all harder to press and things like that. So my other mechanical switch that probably would have got messed up if I tried to use that. So this mechanical switch, plunge style, roller at the end, very high quality, very robust and adjustable height. So you can just move it out of the way, and you can adjust your Ryuta controller to get rid of things, or move it up, or move it a little bit lower if you want to have a little custom thing there. Yeah. So let's go to number 5. So specs, price, and support is where we stand out as a company, right? So this is where I believe our value comes as a company to our customers. And this is the pitch for the laser. We're not building the best $10,000 laser, the best $20,000 laser, a laser that's going to be better than the Trotec maybe one day. But as of right now, this is what we're offering. Customers get a 75 watt, 3 foot by 2 foot bed for around 3,500 Canadian, which for you guys in the US is probably like 2,500 Canadian, right? With your conversion rate. And if something goes wrong, you can call us, fill out a ticket, read our resources, watch our videos, so that you can fix it. That is what we are offering. You get a 75 watts, 3-foot by 2-foot bed for 3,500 Canadian or 2,500 USD. And if something goes wrong, you can call us, you can fill out our ticket system, you can read our resources, you can watch our videos so that we can make sure that we fix the issue, right? That is what our offer is. Specs, good price, and amazing support. That is where we excel as a company. So that is where we are pushing. Zeus, hey, go, spot. Let's do a little check-in on Zeus. How you doing? Wave to the camera. Good boy. Good boy. All right, back to where we're at. So yeah, that's where we stand out as a company. So that's where I want to put our focus in on what we are offering, right? Every company offers something a little bit different. OhmTech offers something different than Glowforge, offers something different than Inventables, offers something different than X-Tools, offers something different than whatever. Fill in the blank. Everybody offers something different, but I think it's about knowing what you offer, knowing what your customers like about what you offer, and pushing on those to continue what people like about it. And I think specs, price, support, that's that balance of three things. Because something could be amazingly spec'd, amazingly priced, but if they offer absolutely no support, you probably won't order it. That's pretty much overseas parts. Why don't you buy a CO2 laser overseas? Because you'll never get support. Something will break and you won't even have a manual, right? Nobody's gonna call you back. Nobody's gonna help you fix that. And some people do that. We did it before. We bought this current machine, the OhmTech one. We did it before because we made that trade-off and we said, we'll just fix things, right? We'll just try to figure things out. You can buy something that's, very cheap and great support, but the specs are bad, and then you're probably going to outgrow it and then probably look to buy something else eventually anyways. And you could buy something that has great specs and great support, but it's going to cost you like 20 grand, 10 grand, 8 grand, even like 7 grand. And that's, a lot of people do make that trade. But what we try to do is offer high value in all three of these categories. Okay, number 7 is develop a few cool features that give customers a better UX, like a user experience, right? So this is where I want to put the ingenuity of design into. So finding a slightly easier way to maybe do an autofocus, right? Even if it's just like the way that the probe mounts to the side, right? Maybe it's a magnetic probe that you use the autofocus and then you move it out of the way, and it clips over to something else, so it's out of the way and you can't crash into it by accident. Like anything, just something that improves the user experience. This is usually where beta testers come in. This is just where using the product every day and getting annoyed at little things and then trying to come up with ways to fix it comes in. And that's something that will continue into the future, even after launch, right? So the next version and next add-ons and things like that. Something maybe with easier mirror alignment, or even easier mirror alignment resources. What I find is that mirrors are kind of mirrors. You're gonna have screws that adjust it and turn it. So, I thought about, maybe doing like very small motors, like even like almost like kind of watch mechanisms to have it so that you could actually digitally adjust your focus, and then you could probably get it to something where you have like machine learning and machine vision to actually auto focus your laser. But that's for the future. It's going to be expensive, and what I say, you can improve things for a reasonable cost because we don't have unlimited budget. So that's maybe something in the future. But even just having the best resources for mirror alignment, going online, going into all the forums, finding out what CO2 users find is the best tutorials, resources for how to focus their mirror, and then creating the best resources, the best video, the best write-up, so that maybe the mirror alignment doesn't change, but we have the best explanation on how to align your mirrors. We have the best videos, the best pictures, the best everything. We explain it the easiest for the most amount of people, and maybe that's where we can have a better user experience, right? Things like making sure our camera is calibrated to light burn, right? Because most people use light burn. It's the best software for lasers, especially CO2 lasers, in my opinion. So might as well make sure that from the get-go, whatever webcam or camera system that we're using in our product is going to be very, very integrated into light burn, so that there's no real issues there. So little things like that just increase the user experience. And then number 8, take some features from more expensive machines and bring them down to our price point. So what I found in my research was a lot of these more expensive machines have belt-covered gantry designs, right? And that makes sure that your linear guides never get too dirty, and it prolongs the maintenance cycle of like making sure that your linear guides are all good and making sure your linear system's all good. Is just to have a bit of like a C channel, and your linear guide sits here, and your belt kind of covers it so that, you know, there's nothing that's getting in there, or there's much less debris. And that's just something I see in like higher quality machines, right? At least 2 inches to 2.5 inches of Z height axis, right? So a lot of the desktop machines, they don't have a lot of Z height. And the big machines, they have a lot of Z height, but it's way too big, and it's heavy and expensive and makes the thing giant in a cabinet. So finding that like having enough, so about 2.5 inches of Z height kind of variance, and like in terms of like the bed size of what you can use, and then having like a high quality Z focus sensor, just so you're never getting annoyed about your sensor or your switch not working properly. And yeah, that pretty much wraps it up. There's like certain like visual designs like the MacBook Mini and the Mac Mini, and like the Bamboo X1 3D printer, and like the Xtools P2 and things like that. Good bed lightings. Yes, I will add that to my list, so thank you. So I'll add that to my really good bed lighting. Thank you. See, this is why Jack in the shop is going to be one of our beta testers, because he's our resident laser demon. He has a CO2, he's very experienced at CO2, and he's going to give us a lot of useful information on what things we can make, we can improve for our laser. So yeah, I think one of my biggest inspirations for enclosures was the Bamboo P1S and the Bamboo X1 Carbon. Obviously, they had a huge budget in order to design the enclosure of this. But I like, if you've ever seen the Bamboo P1S without the enclosure, you just have the chassis. And then if you look at some people who didn't want to buy the enclosure kit that came from Bamboo Labs, they actually 3D printed their own panels and stuff, and used acrylic and 3D printed parts to close their enclosure. And I really love that, because the Bamboo frame and chassis itself is very high quality, very well built. This is like high level industrial and mechanical, and like industrial design, mechanical design, and you know, kind of fabrication and all that stuff for product. That's very high level. But then you have the hobbyists that are like 3D printing brackets to add like their panels to actually close the system, versus like buying the pre-made Bamboo Labs. And the pre-made one looks very nice in the kit, like to enclose all the sides and the top and the glass door. It looks really nice and it's very good. But there's something about this like a little bit of hobbyist kind of edge to it, that when you see like the P1S get converted and enclosed by like hobbyists with their own 3D printed parts and acrylics and whatever, I think there's like that perfect balance between something that's very pretty and industrial design, but something that's very like, you know, still like has the spirit of the long mill, where, you know, we have certain parts that are 3D printed, or, you know, certain parts that are like ingeniously designed. Yeah, so I don't know if you guys have ever seen that, but that's kind of the perfect mix for me. Yeah, so finding a way to like build out the chassis is going to be like a really big design challenge. And for now I'm using extrusion. I might use custom extrusion, but finding a way to like get everything together, right? Like having like a stamped sheet metal chassis would be like really cool, but really expensive. Having like a welded steel chassis, which the Bamboo X1 uses, would be really cool. Scott asks, have you mentioned how exhaust extraction will be set up for the Ultra? No. Oh, I'm sorry guys. I did a thumbs. Every time I do a thumbs up, it crashes my camera for some reason. Let's see if I can do this and then do this, and okay. Are we good? Are we back? No thumbs up. No more thumbs up, okay? It keeps crashing my stream. Doug, thanks for joining us. We're almost done. We have about 5 minutes, but yeah. Scott asks, have you mentioned how exhaust extraction will be set up for the Ultra? No, not right now. That's something that we'll deal with lastly. So for my prototype, I'm figuring out, I just figured out the linear motion. I'm about halfway done figuring out the actual enclosure, then there's going to be the electronics, and then lastly it's going to be like optics and exhaust, right? So that's going to be the last kind of thing that we're figuring out, but it's probably going to be a built-in, pretty powerful inline fan, and then external. So that's something that we found in a lot of other machines, is like people would complain about the fans being more like glorified computer exhaust fans and not really like inline fans. And some machines you actually couldn't add an external inline fan. Some machines you could, but the built-in internal fan wasn't like enough. So maybe we'll have an external fan only, but it'll come stock, right? That might be the thing. Maybe we have enough room inside that we built it in. Maybe we have a small fan that kind of starts the exhaust process, but then we have an inline fan that's very powerful that comes stock, right? So you're not having to buy external things to get really good smoke exhaustion. And then we'll have a 3-phase filter for you guys, and we'll sell the replacements so that you guys can, you guys can replace it, guys. You almost never want to be exhausting. I'll just let you guys know this. You almost never want to be exhausting your filtered air back into like a small enclosed space, right? Even if you have all the filtering, unless you have like a very, very expensive filter. And even then, even if you don't have an expensive filter, you're gonna run through your activated carbon very fast, right? So always just make sure, even like you want to filter it and then you want to get it out, right? Or you want to filter it, but then you want to be in a well ventilated area, right? So I'm just gonna put that out there. But yeah, that's what I have for exhaust, but I'm gonna worry about that last. It's gonna be next is we figured out the motion of it. Next we're gonna figure out the enclosure, and then always need to pipe inside. I feel like some of these desktop style laser cutter companies, they have a 3-phase filter and it's not that great. But even if it was that great, they promote you being able to exhaust the smoke back into your apartment or like an enclosed space, and that's just not okay, guys. This is another one of those things that in the industry, it's just a common misconception that you can just exhaust this after you run it through some filters. And I thought the same thing, right? Until I kept reading on the safety aspect of things, and it's very rare that you want to exhaust this thing. And even if let's say this is your only option, you're in a basement and everything, you need to make sure that place, even if you're filtering it, you're running it through 3-stage filter, activated Australian carbon, you want to make sure that place is so well ventilated. So even if I was filtering, I would have fans on every door, like exhausting out that air and like cycling back in fresh air, so that the air, like even the filtered air that's in my room would get exhausted out, and like I would put so much precaution there. So I'll do a write-up so you guys, and we'll offer kind of what I think is the best option, but I'll also do a write-up for best practices, because I think the industry is misleading people into believing that they can get away with a lot less than they actually need for filtering, or that they're allowed to like refilter it back into like a closed space and not a well ventilated space. So that'll be kind of in the resource section part. But yeah, so far, guys, I think that's going to be it. I kind of opened up my own UltraBeam kind of design philosophy, kind of journal here. I was just reading off of it. And so hopefully you guys have a little bit more insight into what I'm thinking in terms of a machine. But yeah, I am going to call it a stream, guys. It's been about an hour, and you know me, I got to go to the gym. But once again, I'd like to thank each and every one of you guys for joining the stream every week, whether you joined one, whether you joined all 52. I think, Jack, you probably joined at least like 48. Nicholas, you might have joined like high 50s. Like, you guys are the absolute demons. Doug, Nicholas, Scott, Jack, oh, you guys are all the best. Bill, thank you so much. You've joined so many over the past 2 years. I will be back because this is just fun. Even if we weren't doing projects and I like once every 2 weeks, I just come on just like we did now, and I just kind of shoot the shit and answer questions and talk about any updates within the company, and maybe we like react to like stuff where it's like tutorials. Maybe we just like take in like industry stuff, like new CNC machines, new 3D printers, new laser things that we just look and react to videos and that kind of stuff. I'll come back and I'll stream because I just like the streaming. I think I just need a break. I need to be able to refocus on CO2 laser to really push that. And then once I have that kind of working in a system, I'll be back with the CO2 laser, or at least some general reaction news kind of stuff with the live streaming. So thank you so much for joining. This is LaserBeam Live, episode number 52. First of all, thank you to the company CNC Labs, everybody who works there, everybody who does even the tiniest bit to kind of help be in a place like this where I can do this. I'm literally like in my apartment and streaming, and I got my CNC here, and I got all my lighting and camera equipment here. So I am truly blessed, and I am very much appreciative of everybody at the company, everybody who buys something from the company, and everybody who watches this video or is in the community for CNCs, lasers, 3D printers, just anything. It's truly humbling. It's quite cool to be a part of this community, and yeah, just to have a little bit of our own little community. Koala, oh my God, Koala! I feel like I haven't seen your name in the chat in such a long time. You've probably been so busy. Yeah. Bill, thank you so much. Nicholas, thank you so much. Scott, thank you so much. Molly, thank you so much. Lester, thank you so much. Kenny, thank you so much. Gary, thank you so much. I'm definitely forgetting people, but thank you so much. Doug, thank you so much. Koala, thank you so much. Dana's probably not here, but he is huge. Thank you so much. You know the deal. My name is Ikenna for CNC Labs, and whether it's morning, afternoon, evening, or night, I appreciate you spending just a little bit of your time with me. I got a plane to catch early in the morning. I'm gonna go to the gym. I'm gonna drop my dog off at my mom's house, and yeah, you will be seeing me hopefully end of this year, maybe at the latest early next year, with a new show, a revamped show, the new season of this show technically, and we'll keep it pushing. So Koala, thank you so much. You're the best. You guys are all the best. Thank you.